review sections 1.5 to 1.7 in Chapter 1, and this is the pre-assessment. We've introduced solving for variables, and this time variables will be on either side of the equation. So my first step is to gather them onto one side. Since I have the p on both sides, I'm going to work it so I end up with a positive variable. I could have moved the 5p over, but that would have put the constants 24 and the variables on the right side and 0 on the left side. So that doesn't really, it's not very efficient. So it's better, since my constants are already consolidated on the right side, I'll move my variables to the left side. And now we're going to divide by 8 because p is multiplying 8, and the inverse of multiplying 8 is dividing by 8. 24 divided by 8 is 3. And I can check. It's always good to take a second to check. Take that starting equation, plug it in. So we're going to plug in 3, that's a horrible 5, 3 for p, and we're going to make sure that the left side simplifies and the right side simplifies to the same values. 24 minus 9 is 15. That does not mean all real numbers. This is the checking part. So we need to recognize when we get a true statement in checking what that means. It means that this is a correct solution. Number 2, we can distribute. That would be the best way since my variables are inside Chewbacca. It is going to be a nice efficient way. Let's just divide them. So 2 times 3n is 6n, 2 times negative 4 is negative 8, half of 10 is 5, half of n is 0.5n, negative 0.5n. Now I'm going to move my variables first. I always move my variables first. That's the most beneficial. And we're going to look at place values, make sure the 0.5 is adding the 0.5. And we get 5. We're going to add 8. We get 6.5n equals 13. We're going to divide by 6.5, divide by 6.5, and I know that n equals 2. How do you know that, Mr. Mack? You didn't even use a calculator. Well, I know that 6.5 doubled equals 13. So 13 over half its value would be 2. That's a mental math. You should be able to do that. Number 3, we're again going to distribute. Could we divide by 4? Yeah, we could have divided by 4. And we would have gotten 3d minus 1 equals 3d. Or we could have distributed, and you would have gotten 12d minus 4 equals 12d. Either way is okay. I'm going to continue. Well, I'll do both. So here we're going to move our variables. You get 3d, and that gives us negative 1 equals 0, which is a false statement. So number 3 is no solution. If we did it this way, you'd again minus, you'd move the variables, and you get negative 4 doesn't equal 0 again. So both techniques gives you no solution, meaning there is no value that can go in here that would make the left side equal the right side. Most of you probably didn't divide by 4. Most of you probably distributed, so it doesn't matter. I don't care which way you do it. All right, my constants are consolidated on the right side. I'm going to add n over 4, which gives me 2n over 4 equals negative 3. This can be simplified to n over 2 equals negative 3. N is being divided by 2. The inverse would be multiplying by 2. And that gives me n equals negative 6. Here's a cool thing. Let's say, let's take this one, let's copy it and paste. What if I wanted to do this? What if I wanted to get rid And I'm going to get rid of that number here. Let's do this so we can write it properly. So what if I wanted to get rid of the fraction, the denominators? What could I multiply? Well, I could multiply by the common denominator, and I'd multiply everything by 4. And what does that look like? That gives me n equals negative n minus 12. So we're going to add n to both sides. That gives me 2n equals negative 12. Divide by 2, n equals negative 6. Same answer, different technique. I don't care which way you use. Let's distribute. Before we start moving, we have 21 minus 7w equals 21 minus 7w. At this point, a red flag should go up in your head, and you should assume or know what solution you would be expecting. Let's move the variables first. And that leaves me with 21 equals 21. And that would be all real numbers. That is the only answer I'm going to accept. I guess I didn't check those other ones, did I? I checked the first one. I didn't check the second. Let's go back to 2 and check. My solution is 2. So if we plug in 2, so that's 6 minus 4, that's 2, and that gives me 4, 0.5, 10 minus 2 is 8, half of 8 is 4. Does 4 equal 4? Yes, that means the solution is correct. No solution on 3, so there's nothing to check here. We can check this one. So it says it's negative 6. So if we have n over 4 equals negative n over 4, I think it's minus 3. Is it minus 3? Yes. And we say n equals negative 6. So negative 6 over 4. Ooh, I like this check. Negative 6. That negative is not this negative. It is the opposite. And the negative goes in for n. So this negative is here, and this negative is for my n value. So what are we left with? We're left with negative 3/2. I just simplified that. This produces 3/2 positive because the two negatives, minus 3. Negative 3/2 is already simplified. Let's get common denominators. How many halves are in 3? 6/2. And we get negative 3/2 equals 3/2 minus 6/2 gives me negative 3/2. So my solution worked. So that is the correct solution. Always good. All real numbers. Well, what we could do to test this, checking it, we can pick a number. We can check by picking a number. Let's pick 0. Let's pick 1. 1 equals 7 times 3 minus 1. 21 minus 7 gives us 14. Hello. Yeah, gives us 14. That was right. 7, 3 minus 1 is 2, gives us 14. So it worked with 1. Now let's see if it works with another one. Let's pick 2. 7 times 2, 7 times 3 minus 2. 21 minus 14 gives us 7. 7, 3 minus 2 is 1, 7. And we could pick another one, and once it gets 3, we can pretty much assume that it's all real numbers. All right, you bike for 3 hours to reach the beach. We are on a bike, and this is my bicycle. And we're going to go to the beach. To the beach, do. And here's my shovel. Okay, and that's the beach. And could we have a... And that's my shade. So we know that distance equals rate times time. And then we use the same return trip, so we're going to go back home. And that's going to be distance equals rate times time. Distance 2 and distance back. So you biked for 3 hours to reach the beach. So we know that time equals 3 hours. That we know. Using the same route, the return trip takes only 2 hours. 2.5. So I know my time back is going to be 2.5 hours. Okay? And I travel 2 miles per hour faster. All right, so my rate, I don't know the rate of speed there, so we'll do R, but I know my rate of speed back home is going to be 2 miles per hour faster. So R plus 2. So we know that the distance to the beach should be equal to the distance coming back. Did I call it T or B? Sorry, B, back. And we know that distance equals rate times time, and distance equals rate times time. So the rate of speed going to there is going to be R. The time was 3 hours, and the distance or the rate going back was R plus 2, and the time was 2.5. So let's simplify. That's going to be 3R equals, we can distribute to simplify. That's going to be 2.5R plus 5. If I take 2.5s, I get 5. Let's minus 2.5R. That gives me 0.5R equals 5. We'll divide by 0.5, divide by 0.5, and R equals 10. I didn't have to do any math or calculators. I thought about how many halves are in 5. How many halves? There's going to be 10 halves in 5. So my answer is 5. That is the rate of speed going there is going to be 10 miles per hour. And what would the speed coming back would be 10 plus 2 or 12 miles per hour. Is that the question they're asking? How far did you bike? So I need to use one of these distance formulas. I can either use this as the distance, because this distance equaled this, which simplified to this, or I can use this. Which one's easier? Well, R equals 10, I'm going to use this one. So I substitute distance equals R, which is 10, and my speed, which was, or my time, which is equals, distance equals rate times time. My rate is 10, and my time was 3 hours going there. So distance is going to equal 30 miles to the beach. And that would be my answer. All right, now we have absolute value. We know that absolute value equals distance. So what distance inside here, if this was all covered up, what distance would give me, what number would give me a distance of 11? Well, we know that negative 11 and positive 11. So I'm going to set this inside box equal to 11, or x plus 6 can equal negative 11. We're going to subtract 6, x equals 5, and we're going to subtract 6, and we get x equals negative 17. Let's check it. So if we have the absolute value of x plus 6 equals 11, plug in 5. 5 plus 6. Absolute value of 11 is 11. Does 11 equal 11? Yes. Then that is correct. Let's plug this one in to this equation. Negative 17 plus 6 equal 11. That's negative 11. Absolute value of negative 11 is 11. Does 11 equal 11? Yep. Then that is the correct solution. The way that we can write that is negative 17 comma 6. Negative 17 comma 6 is how we would write the solution set. First of all, we should automatically notice I was about to write two equations, but I was going to write the positive and negative, and we know that no absolute value will ever pop out a negative distance. So my answer is no solution. I don't have to do anything more. I don't have to show anything. I know that no absolute values can equal a negative number, so I can just write no solution. All right. When we have absolute values and things are being added and subtracted, our first step is to isolate the absolute values. So let's get rid of that negative 9 by adding 9. We get the absolute value of 3x minus 6 equals 6. And now we're going to separate them. We're going to write two equations. 3x minus 6 equals 6. And 3x minus 6 equals negative 6. Add 6, add 6. 3x equals 12. Divide by 3. X equals 4. Add 6, add 6. 3x equals 0. Divide by 3. X equals 0. And we have to check because we have to make sure that there are no exclusions. Remember, we can get exclusions in these problems. So we have to make sure that these are viable problems. I don't know what happened there. What did I just do? Hopefully nothing too drastic. All right, so let's check our answers. Let's paste that one more time so we can check both of them. Let's put that there. Let's get a pen going. We're going to check x equals 4. So we're going to plug in 4 for x and simplify to make sure the left side equals the right side. 12 minus 6 minus 9 equals negative 3. That's going to be the absolute value of 6 minus 9. Absolute value of 6. 6 minus 9 is negative 3. Negative 3 equals negative 3. So I know that this was a solution. Let's check x equals 0. So 3 times 0 minus 6 minus 9 equals negative 3. 3 times 0 equals 0. 0 minus 6 is negative 6. Absolute value of negative 6 is 6. 6 minus 9 is negative 3. And negative 3 equals negative 3. So I know this. So my solution set is going to be 0, 4. 0, 4. Okay? Important to check them. All right, now we have an absolute value equaling an absolute value. So we make two statements and we pop out 2m plus 6 equals the positive value of that right absolute value, and 2m plus 6 equals the negative value of that absolute value. We're going to subtract 2m. We get 6 equals negative m. We can multiply by negative 1 because we are solving for positive m. So m can equal negative 6. Let's minus 2m minus 2m. You get 6 equals negative 3m. Divide by negative 3, and we get negative 2 equals m. Let's check them, see if those work. Let's copy that. That worked last time quite well. Copy. Let's check our solutions. Paste. Paste. Bueno. Go back to the pen. Let's check. And we're checking negative 6. So 2 times negative 6 plus 6 equals the absolute value of negative 6. 2 times negative 6 is negative 12 plus 6. Absolute value of negative 6 is 6. So absolute value of negative 6 is 6 equals 6. Yes. So that solution worked. Let's do 2 times negative 2 plus 6 equals the absolute value of negative 2. That's negative 4 plus 6 equals 2. This is absolute value of 2 equals 2. 2 equals 2. That's good. So those are my two solutions, -6, -2. Numerical order. Number 11. Now, just because there's a constant out there doesn't mean that we change anything. We're still going to take the positive value of the left and we're going to equal it to the positive value of the right. Absolute values now become quantities. And then the other one is the positive value of the left equals the opposite of that. So we introduce a negative into that. Let's distribute. 3x minus 8 equals 8x plus 2. Subtract 3x. We're going to move the variables first. -8 equals 5x plus 2. Minus 2 minus 2. -10 equals 5x. Divide by 5. -2 equals x. That's one possible solution. We're going to distribute that out. 3x minus 8 equals -8x minus 2. Well, let's add 8x. So I end up with a positive variable. That's 11x minus 8 equals -2. Let's add 8. 11x equals 6, positive 6. Divide by 11. X equals 6/11. That's going to be fun to check. We're going to take this, copy it, and we're going to check it. Let's check it out. Check, check. 1, 2. Let's make that a little bit smaller. Let's copy, paste the smaller one. Let's plug them in. So we get the absolute value of 3 times -2 minus 8 equals 2 times the absolute value of 4 times -2 plus 1. So 3 times -2 is -6 minus 8 equals 2 times the absolute value of -8 plus 1. 6 minus 8 is -14 equals 2. That's -7. Absolute value -14 is 14. 2 times the absolute value of -7. Absolute value of -7 is 7. Does 14 equal 14? Yes, it does. So -2 is a solution. What was my other one? 6/11. Okay. Absolute value of 3 times 6/11 minus 8 equals 2 times the absolute value of 4 times 6/11 plus 1. 3 times 6/11 is very simple. It's 18/11 minus 8. And I'm going to turn this into 88/11 in this step. We can do 2 steps. And that's 18. Didn't improve it very much. 4 times 6/11 is 24/11. And we're going to turn 1 into 11/11. 18 minus 88 gives me 70/11, -70/11, absolute value. 24/11 plus 11/11 gives me 35/11. The absolute value of -70/11 is 70/11. Absolute value of 35/11 is 35/11. 70/11 equals 2 times 35/11 is 70/11, and we get that. So I know that my solution is -2, 6/11. Number 12. Okay. We're going to set it equal to the positive 6n and the negative of 6n. That's minus 3n, minus 3n. 18 equals 3n. Divide by 3. 6 equals n. Subtract 3n, subtract 3n. 18 equals -9n. Divide by -9. -2 equals n. Let's check it. Let's copy. We've been very good about this part. Copy, paste. paste, paste. Okay, let's test 6. 3 times 6 plus 18 equals 6 times 6. 3 times 6 is 18 plus 18 equals 36. 18 and 18 is 36. Absolute value of 36 is 36. Does 36 equal 36? Yes, it does. Now let's look at this. 3 times negative 2 plus 18 equals 6 times negative 2. 3 times negative 2 is negative 6 plus 18. 6 times negative 2 is negative 12. Negative 6 plus 18 is 12. Absolute value of 12. Does 12 equal negative 12? No. That's false. So this is an exclusion. Or did we, what's the other word? It's not exclusion. Is it exclusion? I keep calling it exclusion, but I don't think it's an exclusion. Let's take, I feel like I'm using the wrong term. Let's take a look, see, not 7. They are called, it is with an E, and it is called extraneous. My bad. It's an extraneous. I don't even think that's how you spell extraneous. Extraneous solution. Means it's not a solution. It's not a doma. So my only answer is going to be 6 in this case. Negative 2 is extraneous. All right, let's do this. So we have 2r minus 4 equals the positive side of that, and 2r minus 4 equals the negative. So notice that I included parentheses here in order to show the distribution of that negative into that right absolute value. Let's subtract 2r. We get negative 4 equals 10. No solutions coming from this side. And now let's look at this. We get 2r minus 4 equals negative 2r minus 10. Let's add 2r. 4r minus 4 equals negative 10. Let's add 4, 4r equals negative 6, divide by 4. R equals negative 3/2. Can't give me 6/4, negative 6/4. You have to simplify all fractions. Copy. Let's test this. Let's check it, excuse me. Let's paste. So let's check. We're going to check negative 3/2. 2 times negative 3/2 minus 4 equals the absolute value of 2 times negative 3/2 plus 10. This gives me negative 3 minus 4 because these cancel. This is going to give me negative 3 plus 10. So this is the absolute value of negative 7. This is the absolute value of 7. Absolute value of negative 7 is 7. Absolute value of 7 is 7. So that tells me that this worked, and my only solution is negative 3/2. All right, we're still working. We're getting there. Solve for y. All right, we are on to section 1.7 now. We have multiple variables in these problems, and we're going to solve for a specific variable amongst other variables. So this is pretty straightforward, basic one. We're going to get rid of things being added and subtracted. Sorry, my brain's melting. First, these cancel. Negative 4y equals negative 7x plus 12. We're always going to put our variable in front of our constant. Now we're going to divide by negative 4, and I'm going to do it by each of them, what you do on the left side, multiplication and division, you have to do to every term on the right side, multiplication and division. Only multiplication and division. This gives me 7/4 x. These two negatives must be simplified, and that'll give you -3. I like that answer. That's the best answer. The other way that people could have done it, 7x minus 4y equals 12. Subtract 7x. -4y equals -7x plus 12. And you could have divided by 4, and you get y equals -7x plus 12 over -4. Now, a lot of math teachers will not accept this because of that double negative. Also, you cannot, in this form, you cannot cancel those two negatives because this -4 is also under the 12. So that's probably not going to be a great one. We hate leading with negatives. There's so many things that teachers won't like in high school and in college about this final answer. This is not a good one. Not great. This is the best. Best answer. The majority of your teachers would rather see that. Number 15, now we're solving for W. We notice that we have two W's and we're adding, but these are unlike. So we cannot combine them. But we have to isolate them. We have them in two places. So since they're multiplying everything, we can factor out a W. That gives us 3 plus 4p equals A. And that works, and we love it because now we were able to go from 2 W's to 1 W. And that W is being multiplied by 3 plus 4p. And so we would divide both sides by 3 plus 4p. That isolates our W. And you get A over 4p plus 3. We want to put our, that looks like a 9, but it's an A. And that didn't make the A much better. So we get that. And we'd want our variables before our constants. Number 16, we're solving for L. Minus 2W, minus 2W. You get P minus 2W equals 2L. Divide by 2, divide by 2. And P minus 2W over 2 equals L. And I'll take that. The other answer that you could give is we can turn that 2 under both of those terms. And then we can simplify that and do P over 2 minus W equals L. That's another answer you can give. You also could have written 1/2 P minus W equals L. That's turning P over 2 into 1/2 P. That P better look like it is even with it. If you write 1 over 2P minus W, that would be wrong. That P cannot be in the denominator. It's in the numerator. It's in the numerator. So be careful what you write. On a July day, the temperature at the peak of Mount Everest is -16 degrees Celsius. Is that temperature warmer or colder than 0 degrees Fahrenheit? So let's take that. We're given, use the formula C equals 5/9 F minus 32. So if I plug in -16 degrees Celsius, that's going to go in for C. 5/9 F minus 32. I'm converting this, convert to degrees Fahrenheit. So how do I simplify this? Well, I wouldn't distribute it. That would be actually too much. What I can do is I can multiply by the reciprocal of 5/9, which is 9/5. That'll cancel these two. What I do to one side, I do to the other. 9/5. So 9 times -16. I don't know that off the top of my head. I probably could do it, but it's much easier. 144. So we would get negative 144 over 5 equals F minus 32. Okay, let's add 32. Let's add 32. So we have negative 144 fifths plus 32 equals my degree in Fahrenheit. I want to get fifths. So how many fifths is 32? That's going to be 160. Negative 144 fifths equals F. And 144 minus, negative 144 plus 160 gives me 16 fifths equals F. And that would give me 3 1/5 degrees Fahrenheit, or 3.2 degrees Fahrenheit. So it says, is it warmer or colder than 0 degrees Fahrenheit? It is warmer. 0 degrees, negative 16 degrees Celsius is equivalent to 3.2 degrees Fahrenheit, which would be warmer than 0 degrees Fahrenheit. So the answer would be warmer. Number 18, you deposit $3,500 into an account that earns simple interest at an annual rate of 4%. How long must you leave the money in the account to earn $350 in interest? Okay, so let's take these pieces. 350 interest, that's going to go in for I. 4%, that's going to be the rate. That was horrible. That's going to be the rate. You deposit 350, that's going to be my principal. And we notice that we are, where's my question? How long? And that's going to be time. I'm looking for T. And time is going to be in years. We need to remember that. So I'm going to plug those in. 350 is the interest, equals the principal is 3,500 times the rate. Rate 4% is 0.04 times T. So I'm going to simplify the right side first. And I'm going to multiply 3,500 times 0.04 gives me 140 T. And I'm going to divide that by 140. And let's do 350 divided by 140 equals 2.5. So 2.5 equals T. So after 2.5 years, or we could have said 2 years, 6 months, either one is acceptable. That's how long it will take if I deposit $3,500 at a rate of 4%. I will earn $350 in interest after 2.5 years. Not bad. All right, last question. Here we go. Your cousin averages 60 miles per hour while making a work delivery. On the return trip, your cousin averages 45 miles per hour due to weather. The total driving time is 5 hours and 15 minutes. How long does each trip take? Well, let's convert this into complete hours. So 5 hours and 15 over 60. So 15 over 60 is 1/4, which would give us 0.25. 15 divided by 60, 0.25, yes, equals 0.25 hours. So this time, total time, equals 5.25. So I know that if we look at time, and this is the tricky part, the total time is 5.25. But I don't know how much they go to going to work. So going to work, go to work is going to take me a certain amount of time. And then on the return trip. So when they go on the return trip, return is going to be another time. I don't know what that is right there. Go to, oh, that says work. I didn't know what that said. W-O-R-K. And return is going to be another amount of time. But those two added up is going to equal 5.25. So what I can do is I can say, hey, this will give the variable t. And this one, I have no idea. But if I add t plus this other one, it's going to equal 5.25. So if I wanted to solve for this question mark, I would just subtract t from both sides. And that would give me that missing piece, the return, would be equal to 5.25 minus t. So we will give that as the time for the returning, and t as the time going to work. So now when we look at the situation, we actually have a value for time. So this guy's going to work, and distance equals rate times time. The rate of speed going to work was 60, and the time is going to be t. Remember how we associated that? And then coming back is still going to be d equals rt. And the rate of speed, I think, was 45 going back. And time, remember, we gave it 5.25 minus t. So if we know that the distance 2 is going to be the same as the distance back, let's plug in our r and t and our r and t. 60 times t is going to equal 45 times my t for returning was 5.25 minus t. And now we can simplify it. 60t equals 45 times 5.25. 45 times 5.25 gives me 236.25. 236.25 minus 45t. We're distributing to both of those. Let's add 45t. Add 45t. That gives me 105t equals 236.25. Let's divide by 105. Divide by 105. T equals, so we got 236.25 divided by 105 gives me 2.25. 2.25 hours. Now remember, t represented the time to, where'd we go? Where were we going? To the beach, to work. To work delivery. So if I want to find what was the time coming back, we can remember this little, where was my little indicator? Let's see, was it up here? Yes. So this is a return. So this is my return. So if t equals 2.25, I can go here and I can write 5.25 minus 2.25. And so that gives me 3 hours returning. So it took me 3 hours to return. It took me 2.25 to go to it. And those are my two, I think they asked for each of those. Total driving time is 5 and 15 minutes. How long does each trip take? So it takes 3 hours to return, and it takes 2.25 hours to go to work, or 2 hours and 15 minutes if you want to give that in minutes and hours. I'll accept either of those. Those are the same answer. Woo, baby. That was good work. All right, good luck. Study. I'm excited for you to take it.